approximation using left bar. Okay, where x0 is equal to a, x1 is a plus 1 delta x, x2 right here is a plus delta x plus another delta x, a plus 2 delta x, and then x3 right here is a plus 1 delta x plus 2 delta x plus 3 delta x. Okay? That was the approximation using the left bar, the left side of the rectangle. And what if we ask for the exact answer instead of approximation? Then you guys are going to take the limit when n here, instead of equal to 4, take the limit when n go to infinity. Another work, we're going to chop it up into many columns. And the width that x now is going to be very tiny, because what? B minus a divided by a huge number. You have a lot of little columns, okay? Now what? Since that x is very small, then what? The left line and the right line right here, called the left bar and the right bar, going to be very close to each other, and the difference is going to be very small. And when you take the limit when you go to infinity, you will have the exact answer for the area bounded by the curve. The left, the vertical line x equal to a, vertical line x equal to b, and the x-axis. Okay. And in his for left approximation, what if you want to do the right approximation? The same problem right here, same example. I got 4 columns in here. What if I want to do R4? R4 right here means I want to chop the area into 4 columns, okay? And then I want to approximate, make that way. The area above the x-axis, below the curve bounded by x equal to a, x equal to b, using the right bar for each column. So let me use the red column. See, if I use the right bar for each column, the first column is not from here to here anymore. This is my first column, so it's overestimated a little. And the second column is going to be from here to here, overestimate a little. Going to be underestimate a little right here, and then underestimate a little right here for the fourth one. So R4 is what? Delta x, okay, which is the width right here, not times x0 anymore. The first one going to times f of x1. Because this x1 is a right bar for the first column. And then similarly, delta x and f of x2, delta x and f of x3 for the third column, and delta x and f of x4 for the fourth column. So for the left, we start with 0, 1, 2, 3. For the right approximation, we do what? 1, 2, 3, 4. And I got x3 right here, so x4 is b, which is a plus 4 delta x, which is b. Okay? So we don't use a anymore, we use from x1 all the way to x4. And we have a different approximation. Of course, the left approximation may not, most of the time, will not be equal to the right approximation of the same area. Pretty close, but not the same, because you use different values. However, if you take the limit, okay, means what? N is not equal to 4 anymore. We chop into what? 4,000, 4 million, 4 trillions of columns, and go to infinity. And it turns out what? The difference gonna be, it go to 0. And we have the same answer. And that's called the exact area, okay? So, let me write it in general instead of 4. We chop it up to n, okay? N could be any number. So delta x is b minus a over n, okay? x0 will be a, x1 is a plus delta x, x2 is a plus 2 delta x, x3 is a plus 3 delta x. So in general, xi is equal to a plus I delta x, all the way to xn is equal to a plus ln delta x, which is equal to b. Okay, we chop it up into n columns. N could be any natural number, and then you can use the left or right approximation. Let's do left approximation called ln. Okay, is what? Delta x times f of x0, because you use the left, we start with x0, okay, plus delta x, f of x1 plus data all the way to delta x times f of xn minus 1, because we will stop right here, the second one from the last. This is the last one is xn, and the one right before is going to be xn minus 1. Since everything got delta x, you guys can factor delta x out as a common factor. F of x0 plus f of x1 all the way to f of xn minus 1. And this is the left approximation. Similarly, the right approximation, Rn, will be delta x times, now guess what? The first function is not f of x0 anymore. It's going to f of x1 plus f of x2, and the last one will not xn minus 1, because now we are using the right bar. And the last one is going to be f of xn. Okay? Again, ln and rn may not be the same number. It's be off a little because we are doing an approximation. But if we take the limit, then what? We claim that the limit of ln when n go to infinity going to be equal to the limit of rn when n go to infinity, equal to the actual area. Okay? And you know what? The area is denoted this way. It's integral. The notation of integral that we just learned before. And we have a subscript A in here, superscript B right here, so boundary, lower bound, upper bound of the function f of x from A to B, dx. So this notation now, this integral notation that we introduced you a minute ago, along with the lower bound A and the upper bound B, just indicates what? The area bounded by the curve of the function f of x, the x-axis, and the two vertical lines from x equal to A all the way to x equal to B. Okay? And with A and B right here, we call it the definite integral. And now you got the idea of definite integral. It's no more than what? For now, okay? The area of the region bounded by the function, the x-axis, and the two vertical lines from A to B. Okay? And people ask, why do we have to use left or right to approximate the area? Can I use the middle line? And of course the answer is yes. And now you got what? M stands for the middle, okay? And then you don't have A, you don't have B right here. You call what? This is what? X bar 1, X bar 2, and you're going to calculate those points. Let me give you an example. You see it? What if this is 1 and this is 5? Okay. So if I jump it to 4, and this is what? 2, 3, 4, right? Is that obvious? What about the middle point right here? It's going to be 1.5. This is 2.5. This is 3.5. This is 4.5. And what is so good about the middle point? You kind of neutralize the error. So if you use the middle line, this is going to be your rectangle you're talking about. This is a little bit overestimate right here, a little bit underestimate right here, some kind of neutralize between the left and right, and similarly, middle point, and you can calculate the area. So, say M4 is what? Again, delta x is the same.